what is a line segment, ray, then congruent segments, property of congruent segments, midpoint of a segment, comparison between two line segments, perpendicularity, and distance of a point from a line. Now based on these all, we have our practice set 1.2. In case you have not watched those videos, you can go and watch them again. So it will be very helpful for you to connect with the next part of the exercises. Understood? Now see the first sum of practice set 1.2. Here one table is provided to you in which some point and coordinates are given. Right? Now we have to calculate distance between two segments and we have to compare if they are congruent or not. So see the first sum, set DE and set AB. So we'll take the coordinates of DE first. Here coordinate of point D equals to, it is -7, and coordinate of point E equals to 9, right? So therefore seg DE equals to, as you all know that 9 is greater than -7 and we have to subtract the smaller value from the greater one as we have done in 1.1. The same way we will solve here. 9 minus -7 is equal to 9 plus 7, that is equal to what? 16. Right? This will be our equation 1. Seg DE equals to 16. Then we'll go for AB. Here coordinate of point A equals to -3 and coordinate of point B equals to 5. Therefore seg AB is equal to 5 minus -3, that is equal to 5 plus 3 equals to 8. What you can say after solving these two equations? First one is 16 and second one is 8. It means what? They are not congruent, they are not equal. So we'll write from equation 1 and 2, seg DE is not congruent to, seg DE is not congruent to seg AB. Right? Now we'll see second sum. It is BC and AD. So coordinate of point B is equal to 5. See here, from the table you have to take the coordinates. Coordinate of point C equals to 2. Therefore seg BC equals to 5 minus 2, that is equal to 3. This will be your equation 1. And for AD, coordinate of point A equals to -3 and coordinate of point D equals to -7. As both the values are negative, here -3 is greater than -7. So we'll subtract -7 from -3. Seg AD equals to -3 minus of -7 equals to -3 plus 7, that is equal to 4. Here also what can we say? Both the equations are not equal, so segments are not congruent. So write down from equation 1 and 2. From equation 1 and 2, seg BC is not congruent to seg AD. Right? This way we have done with our second sum. Now see the third sum. Seg DE and AD. Now here coordinate of point B is 5 and coordinate of point E is 9. So sec BE equals to 9 minus 5, that is equal to 4. This is our equation 1. And for AD, coordinate of point A is minus 3 and coordinate of point D is minus 7. Therefore, sec AD is equal to minus 3 minus of minus 7 is equal to minus 3 plus 7, that is equal to 4. This is our equation 2. So we can say that sec BE is congruent to sec AD from equation 1 and 2. So write down from equation 1 and 2 sec BE congruent sec AD. Right? Now see the second sum. Point M is the midpoint of sec AB. If AB equals to 8, then find the length of AM. As you all know that midpoints divide the segment in two equal parts. So see here, I am drawing one line segment for you. Here this is AB and point M is the midpoint of AB. It means what? AM is equal to BM. Now there are two ways in which we can write, like here AB is given, so we can write AM is equal to BM as M is the midpoint of sec AB. Right? This is given to you. AM is equal to BM, that is our equation 1. Because of this property, AM is equal to BM. Now if the segments are equal, then we can write AB is given 4. So I can write AM plus BM is equal to AB. Now I can write twice AM plus AM is equal to AB. 2AM is equal to 8. AM is equal to 8 upon 2. AM is equal to 4 units. Okay. So length AM equals to 4 units. Now in the same way we have our third sum. Point P is the midpoint of sec CD. If CP is equal to 2.5, find length CD. Right? Again I will draw one line segment, that is CD, in which P is the midpoint of CD. So CP is equal to PD or DP. This is your equation 1. Either way we can write that CP is equal to half into CD. This is also one way to solve the sum instead of taking parts. So here CP is given 2.5. Here half into CD, as we don't know the value of CD. Here we can write because P is the midpoint of seg CD. Therefore, CD is equal to 2.5 into 2. CD is equal to 5 units. Now, see the fourth sum. If AB equals to 5 cm, BP equals to 2 cm and AP equals to 3.4 cm, we have to compare the segments. Now, we have seen in previous part how to compare. Means less than or greater than. So here I will compare with the measurements first. Your 5 is greater than 3.4 and 3.4 is greater than 2 centimeter. It means what? AB is greater than AP and AP is greater than BP. We can either write in other way, BP is less than AP and AB is less than AB. Right? Now see the fifth sum of practice set 1.2. We have few sub questions in this, and the first one is write the name of opposite ray of ray RP. So here RP is given. This is the ray. We have to find what is the opposite ray of RP. So if I consider this, I will say that RS or RT. RS or RT is the opposite ray of ray RP. So your answer will be ray RS or ray RT are the opposite rays of ray RP. Now see the second one. Write the intersection set of PQ and RP. Now see here, it is PQ and RP. Now if we compare it with set, then in case in set A you have 1, 2, 3 elements, and in set B you are having 3, 4, 5. Then what will be the intersection of A and B? It is 3. Right? The same way we have to see this sum. Write the intersection set of PQ and RP. PQ and RP, its intersection is ray PQ, because RP ray will not stop here. It has to move further. So PQ is the intersection of RP and PQ. So here your answer will be ray PQ. Okay. Now third one. Write the union set of PQ and QR. PQ and QR. So union means what? Here in this sum only, if I take the union of A and B, I'll write 1, 2, 3 and 4 and 5. Right? The same way, if I take union set of PQ and QR, it means what? It will be line QR. Line QR, or you can write line RQ. Yes? Then comes fourth one. State the ray of which QR is a subset. So QR is the subset of itself first of all. Then it is subset of QS and subset of QT. So your answer will go like this. The ray of which QR is subset. For this we will write set QR is subset of ray QR, ray QS and ray QT. Okay. Then fifth one. Write the pair of opposite ray with common endpoint R. Now if I consider this as common endpoint, I can write RQ and RT. RQ and RT as opposite rays. You can even take RS and RP, that is also correct. Now see the sixth sum. Write any two rays with common endpoint S. Here with common endpoint S, we have two rays as ST and SR. You can even go for SP or SQ. Understood? Then the last sum. Write the intersection set of ray SP and ray ST. So intersection of ST and SP will be what? Point S. So point S is the intersection of ray SP and ray ST. Now children, we have seen this exercise, and the last sum of this practice set will solve in interactive session. Thank you.